Okay, so let's talk about multiplying radicals here. So we've already learned about adding and subtracting radicals and how they have to have the same radicand and the same index. When you are multiplying radicals, they do not have to have the same radicand, but they have to have the same index. They have to have the same index. If you are dealing with different types of roots, you cannot multiply them together. Period. You cannot do it. So the first thing we're going to do here is say, do they have the same index? The answer is yes. So we can move on from there. Now, the good thing about multiplication and division is that everything is being multiplied together, right? It's 5 times the radical times the number times everything is being multiplied together. So with multiplication, it's commutative. The order of multiplication does not matter. So you can do it either which way. So we're going to move the order around. We're going to bring the 5 and the 3 together, and we can multiply 5 times 3. So you multiply what's on the outside, and then you multiply what's on the inside. So 5 times 3 is 15. And then you have the cube root of, remember your index stays the same, and then you just multiply what's on the inside. So you have negative 12 times 18, which is negative 216. So negative 216. Then you have a times a squared, which is a cubed. And then you have b squared times b to the fourth, which is b to the sixth. All right, and then you simplify from there. So we know how to simplify this. So we have to do the cube root of 216. So you have to ask yourself the question. Is it a perfect cube? I just checked. Yes, it is a perfect cube. 216 is 6 cubed. So the cube root of negative 216 is negative 6. The cube root of a cubed is a, and the cube root of b to the sixth is b cubed. These are all perfect cubes. All of these are perfect cubes, so that means that the cube root goes away. So we get, and the 15 comes down and gets multiplied. So the final answer is going to be 15 times negative 6, which is negative 90 ab cubed. Final answer. Let's try another one together. So we are going to do 6 times 4, which is 24. That is the first thing, 6 times 4. Then you have the square root of 8 times 2, 16. C cubed times c, c to the fourth, and then d to the eighth. And then you simplify. So you have 24 times the square root of 16 is 4. The square root of c to the fourth is c squared, and then d to the fourth. And your final answer, 24 times 4 is 96. C squared d to the fourth. So same thing. What do you get for this one? I want you guys to do it on your own. All right, this should have been your final answer, and you should have gotten an absolute value over y because you had even degree, even degree, even degree, and then it became an odd. So it has to be positive in the end. So let's talk about what happens if we multiply radicals if they are as binomials. So basically, how do you FOIL with radicals? And it is exactly the same thing that it would be if it was numbers, right? Again, multiplication, all that needs to be true is that the index is the same. And for all of these, the index is all what? The index is 2. So we are going to do FOIL. So we're going to do this times this. So 4 times 3 is 12. Square root of 3 times the square root of 2 is the square root of 6. Then the next one, right? You do negative 6 times 4 root 3 is negative 24 root 3. Then we have 5 times 3 is 15 root 4. And then last but not least, we have this, which is negative 30 root 2. Now, there is no like terms, but we can simplify. You always have to simplify and then combine like terms. So first we're going to simplify. So this will just stay root 6. What is this going to become? This is going to become 15 times 2, which is 30. So actually, I'm going to write my final answer over here. And my final answer is going to be 12 root 6 minus 24 root 3 minus 30 root 2. And I always put my constant at the end. That is a practice we always have. And that is my final answer. So try this one next. Here is your final answer after doing all of the distribution. No like terms, nothing to simplify, so you leave it like that. Now, what happens when you multiply conjugates? We've spoken about conjugates before, and conjugates are the exact same binomial except one has a minus, one has a plus. That is what a conjugate is. So what happens when you multiply them? Let's see what happens. So you're going to get 7 root 2 times 7 root 2, which becomes 14 root 4, right? But think about it. What's root 2 times root 2? When you square, which is multiplying something by itself, when you square a square root, you get 14 times, you just get the radicand. I put 12, I meant 14. You get 14 times 2, okay? So that's 1. Then we have 7, 21 root 6 minus 21 root 6 and minus 9 root 9, which this becomes negative 9 times 3, which again is just your radicand. And here is just your radicand. You notice that what happens? I wrote 14, I meant 49. Just making mistakes all over the place. So then these cancel out and you get 49 times 2 is 98. These went away and you get minus 9 times 3 is 27. All right, so then you get 98 minus 27, which is 71. Final answer. Done. Yes, you get a number because these are all just numbers. There's no variables, no nothing. This should remind you of when we worked with complex numbers and the middle terms when we were dealing with conjugates canceled out. So you end up just getting a number. Okay, so that's multiplying. Let's talk about dividing. When we are dividing radicals, you are taking a root of a fraction, right? Because division and fractions are the same thing. Reduce what you can and then simplify the radical. Okay, so let's talk about what I mean by that. Can you reduce 25 over 49? Is there anything to reduce that, the fraction inside, the radicand? No. The radicand is already simplified. There's no common factor between 25 and 49. So you can just take the square root of both this and this. And this becomes, you can split it between the numerator and the denominator and it becomes 5 over 7. Another example. What about this? Well, let's simplify the fraction first. So you have 16 over 36 becomes 16 over 36. What's the common factor? Common factor is 4. So this becomes a 4 over 9. If we simplify this, there's no more x's on top. The x's stay on the bottom. X to the 4th. This goes away. The same thing. Y to the 4th is on the bottom. So there's only a 4 on the top left. And so we have, then we could take the square root of the top and the bottom separately. The top becomes a 2. What does the bottom become? The bottom becomes 3x squared y squared. And that is your final answer. You can take the square root of the inside and then simplify. You could do it backwards. I recommend doing it this way because you deal with smaller numbers in the end. And lastly, we're going to learn about rationalizing the denominator. And you did this, you should have done this in geometry, but we are going to talk about what it is with radicals. And we did this with complex numbers. In math, something you cannot have is, it's just not simplified, is a radical in a denominator. So you have a radical in a denominator here, which is not allowed, right? You can't have this radical too. So we need to make it a non-radical. How do we undo a square? What is the inverse operation of a square? A square root, I mean. The inverse operation of a square root is a square, right? So I'm going to square this. And what's the same thing as squaring something is multiplying it by itself. But we know that we cannot just multiply one thing by itself. You can't just multiply the denominator by something. I'm going to multiply both the denominator and the numerator. Because this, remember, is the same thing as saying I'm multiplying it by 1. And when you multiply something by 1, it keeps it equivalent. It has the same value. So this equals 3 root 2 over, and we squared this, you get root 4 or just 2. And that is rationalized. This is simplified. It is allowed. What about when we have something like, and we're going to just do one more, when you have something like this? How do we get rid of a radical? Well, in a binomial. Well, we spoke about it up top. What do you have to multiply a binomial by to get rid of the radicals? Its conjugate. So we're going to multiply by its conjugate. And it should get rid of the radical in the denominator. So the conjugate of 2 plus radical 3 is 2 minus radical 3. And then you get, and then same thing on the top, 2 minus radical 3. And you FOIL this out. When you FOIL this out, you would get 2 squared, which is 4, and then minus root 3 squared, because remember the middle terms cancel out, root 3 squared, which is not 3, I'm sorry, it's root 9, which is 3, and then on the top, you distribute the 5, you'll get 10 minus 5 root 3, and this 4 minus 3 is 1, anything over 1 is itself, so you just get 10 minus 5 root